You might think this is clickbait. After all, LLMs are the heart of AI hype right now. ChatGPT, Claude, Gemini, all built on massive transformer-based architectures. But when one of the founding fathers of deep learning, Yann LeCun, steps on stage at Nvidia's GTC 2025 and casually says, "I'm not so interested in LLMs anymore," that's not just a soundbite, that's a bombshell. So why would someone at LeCun's level, the chief AI scientist at Meta, one of the key minds behind convolutional neural networks, say that LLMs are not where the future of AI lies? Let's unpack this. First, let's understand what he's walking away from. LLMs, large language models, dominate AI right now. They've proven they can write code, summarize books, tutor math, mimic writing styles, and even pass legal exams. We've seen GPT-4, Claude 3, and Google Gemini do things that 5 years ago felt like science fiction. But LeCun is warning us. We're heading down a dead end if we think this is the full path to AGI. These models are impressive, yes, but they're ultimately doing one thing: predicting the next token. That means when you ask an LLM a question, it's not actually thinking, it's completing a pattern. Based on billions of documents it's read, it's calculating what statistically comes next. That's useful, but it's not intelligence. It's not understanding, and it definitely isn't reasoning about the real world. LeCun breaks it down into 4 major areas that LLMs struggle with, and that any future intelligent system must master: understanding the physical world, building persistent memory, reasoning in complex situations, and planning ahead. He explains that LLMs predict text tokens, individual chunks of language, based on training data. This method works for language-based tasks, but what about environments with continuous, unpredictable variables, like real life? Machines need a model of the world, not just language. That's where his focus shifts to what he calls world models. In simple terms, it's how we understand and anticipate physical events. Like, if you push a bottle from the top, you intuitively know it might tip over. Push it from the side, it slides. That's your internal world model at work. We humans develop these intuitions as babies, and we rely on them every second, even without using language. That kind of implicit understanding is what current AI lacks. LeCun points out that trying to use LLM-style token prediction for physical understanding doesn't really work. Tokens are discrete. You have a fixed vocabulary. But the world isn't made of tokens. It's continuous, high-dimensional, and unpredictable in ways that LLMs can't handle. Attempts to train AI on raw pixel data, like video prediction, haven't been very successful either. These models try to guess what comes next, pixel by pixel, but the world has too many unknowns for that to be effective. For instance, show a model the first few seconds of a video of a crowded room and ask it to predict exactly what every person looks like in the next frame. It can't. There's too much randomness. The model wastes effort trying to guess details it has no way of knowing. Instead, LeCun advocates for a higher-level approach, learning abstract representations. That means training AI not to recreate every pixel, but to grasp the overall structure of what's happening. Rather than guessing the exact shape of a person, the model would understand there's likely a person here and use that understanding to make decisions. This leads to his proposed solution: Joint Embedding Predictive Architectures, or JEPA for short. This system doesn't try to generate perfect images or videos. It learns by filling in missing information in a compressed, abstract way. Think of it as intuition instead of memorization. JEPA models are trained on video data to recognize what's physically plausible and what isn't. They can spot when something doesn't follow the laws of physics, like a ball floating up instead of falling. And instead of mimicking reality pixel by pixel, they understand patterns, like a baby learning by watching their parents. And here's the exciting part: JEPA works. LeCun revealed that version 2 is being trained on longer sequences and is able to detect when a video defies the laws of physics. For example, If an object disappears mid-frame or morphs into something else, JPA flags that as impossible. That's not mimicking, that's understanding. To further explain, LeCun invokes psychology, the concepts of System 1 and System 2 thinking. System 1 is fast, instinctive, reactive. Think, driving on autopilot. System 2 is slow, deliberate, logical. Think, solving a math problem or planning a project. Most AI today operates in System 1, reacting to inputs, but AGI requires System 2. It requires deliberate reasoning, structured planning, and internal goal pursuit. LeCun says current transformer architectures aren't equipped for System 2. They weren't designed for that kind of thinking. And until we build architectures that can reason abstractly, we're nowhere near AGI. Let's talk scale. An average LLM is trained on something like 30 trillion tokens. That's about 10 to the 14th bytes of text. But did you know that a 4-year-old child, just by seeing, processes that much data through their eyes? Seriously, our optic nerves send about 2 megabytes per second to the brain. Multiply that by 16,000 hours of wakefulness, and you get the same data volume as an LLM has read in its entire training run. That tells us something important. Text isn't enough. Human learning is overwhelmingly multimodal. Sight, sound, touch, movement. LLMs are blind, static language machines. That's a huge limitation. Traditional generative models, like diffusion models or GANs, aim to recreate data, but that's expensive. Why waste compute trying to predict every pixel when only a few key features matter? JEPA sidesteps this. Instead of recreating a scene, it predicts the abstract structure of what's next. It fills in missing frames based on what it knows about physics, object behavior, and causality. It doesn't care about exact textures or colors. It cares about what's plausible. So, is this the death of LLMs? Not at all. LeCun himself says that text-based models have their place, especially in communication tasks. But to build real-world agents, robots, planners, assistants that can operate in messy, unpredictable environments, we'll need something more. The future, he predicts, will be hybrid architectures. Systems that combine LLM-like language understanding with JEPA-style physical intuition and planning. Think of it like this. LLMs handle language. Vision models handle perception. JPA handles world understanding. And future models will add reasoning, memory, and goal pursuit. Together, these systems will form something closer to true general intelligence. Here's where we stand. LLMs are powerful, but they plateau on reasoning, memory, and real-world intuition. World models like JEPA are early but promising, and they operate in a way that's more similar to how we think. AGI won't come from scaling transformers alone. It will require new architectures. And most importantly, we're still early. The field is shifting fast. Meta, Google, OpenAI, and others are already experimenting with Omni models, combining text, vision, sound, and memory into unified systems. LeCun isn't saying LLMs are useless. He's saying, don't bet the entire future on them. So what do you think? Are LLMs a one-trick pony, or are they just the first stage of something bigger? Can systems like JEPA really deliver AGI-level reasoning? Drop your thoughts in the comments. Let's talk. And if you want to stay ahead of where AI is actually going, not just what's trending, hit that like button, subscribe, and don't miss the next chapter in the AI revolution.